This video focuses on Kubernetes namespaces and DNS. A Kubernetes namespace is a way for us to take the Kubernetes cluster and divide it up into pieces. Instead of deploying our pods and services into a big pile, we can use namespaces to organize them into groups. So why would we split up our Kubernetes objects, you say? Well, there might be lots of reasons, but here are a few of the common ones. We can use namespaces to separate teams. Namespaces can have access controls on them so that you can specify what users can create or delete pods, as an example. In a similar way, network policies can restrict network access between namespaces if we don't want network traffic to be shared. You can also set resource limits on a namespace. In this way, you can make sure that one namespace doesn't get allocated all of the physical resources of the nodes in the cluster and make another namespace's resources run poorly. And a simple reason is just for their organizational features. Maybe when you're deploying applications, you don't want to continue to see 100 different apps when you run kubectl get pods all the time. Creating a namespace is simple. The YAML file shown on top only requires an API version, a kind, and a name. If you're creating this through an imperative command, just run kubectl create namespace and then the name of your new namespace. It's also important to know how name resolution works in a Kubernetes cluster and how it's affected by namespaces. Each service that is created in a Kubernetes cluster is given a DNS name. The fully qualified domain name for these services is defined by the name of the service, dot, the name of the namespace the service is in, dot, SVC for service, dot cluster, dot local. Pods within the cluster can make a DNS request to this address and will receive the Kubernetes endpoint for that service. If a request only uses the service name and not the fully qualified domain name, then the namespace that the requesting pod is in is assumed. Okay, over to the console to see namespaces in action. So you've kind of been using namespaces this whole time in your labs. When you don't specify a namespace, it's put into the default namespace. If we run kubectl get namespaces, you can see we have one called default, and you'll see we've got a few others in there as well. See, that organization feature namespaces give us can be used to hide things we don't want to see all the time. Okay, let's create a new namespace by running kubectl create namespace, and then the name of our namespace will be called Tiger Team. Rerun our get namespaces command, namespaces abbreviated as NS, and you can see we now have a Tiger Team namespace. Now I'm going to deploy some pods and a service into the Tiger Team namespace. You can see in the deployment file that I've specified a namespace under the metadata fields of both the deployment and the service to put these two objects in our new namespace called Tiger Team. If I run kubectl get pods, they don't show up. But you're probably already realizing the issue due to the message about there not being any resources in the default namespace. We need to run that same command again, but this time add a -n and the name of our namespace. There they are. And if we repeat this with services, abbreviated SVC in this command, we can see app1 on port 8080. Let's test out DNS quick by running that curl pod we've used previously in other labs. We'll run the pod and get an interactive terminal inside the pod. Then we'll run curl and put the fully qualified domain name of our service in the request. So we need to curl app1, which was the name of the service, the name of the namespace, which was Tiger Team, and then svc.cluster.local. And we need to specify the port the service was on, which was 8080. We get our Welcome to Nginx page as expected, proving that our pod was able to resolve the DNS name of our services. Enjoy your lab where you'll get to create your own namespaces and test DNS.